Good morning, my dear friends. Myself Dhiraj Mandal. I welcome to this session of fluid mechanics. Okay, so last class I discussed about the viscosity. So up to this, the three lecture has been uploaded. This is my fourth lecture, and this lecture is on kinematic viscosity and rest of the fluid property. Okay, so first of all I would like to say that um, you have to go to my YouTube page or YouTube channel, that is name is your study corner. Okay, and you write down study corner, fluid mechanics study corner. This is how you can write, and all the notes you can follow, you can get from in my Telegram page. Okay, so I am going to start this fourth lecture, that is your kinematic viscosity. So what is kinematic viscosity? It is basically defined as the ratio of dynamic viscosity and the density of the fluid. So this nu, basically it is called nu. This is a Greek symbol, as you can see. Nu is equal to viscosity, it is denoted by mu, already we know, and density is your rho. So nu is equal to density, viscosity by density. So the unit should be, what is the unit? You know that all of you know the unit of the viscosity already, it is discussed in the last class. So Newton second per centimeter square or dyne second per centimeter square, that is your called poise. So all of you know this one. So this is your viscosity and density. What is the unit of density? Kg per meter cube. So this unit is very important. Remember, when you are finding out some problem and numerical is there, then this unit is necessary, and always SI unit you should take in SI unit. Okay, so the mu is equal to, we know that mu by rho. Now the mu is equal to force into time per your Newton second per centimeter square. So ultimately if you are putting that one, so force into time by length square into mass by length cube. Okay, so this is your rho and this is your viscosity. So ultimately after trimming this equation you will be getting length square by time. So length square means your meter square, and this is your second. So the unit should be your meter square per second. Okay, so that is called your that is the unit of the kinematic viscosity. Okay, now 1 stroke is equal to 1 centimeter square per second, or 1 by 100 square 100 square meter square per second. So 10 to the minus 4 meter square per second. So this is your CGS unit. So 1 stroke is equal to centimeter square per second. So CGS unit, your centimeter square per second, it is also called 1 stroke. Okay, STOKE. So centistroke means your 1 by 100 stroke. Okay, so these all this it should be known to you. Okay, now I am coming to the Newton's law of viscosity. So according to the Newton's law of viscosity, basically it states that shear stress tau on a fluid element layer is directly proportional to the rate of shear strain. The constant of proportionality is called the coefficient of viscosity, and mathematically it is expressed as tau is equal to mu into du by dy. What is mu? It is your viscosity, dynamic viscosity. Okay, so this is your mu, and the du dy is your rate of shear strain, and tau is the stress. So that is told in by Newton's law of viscosity. Now fluid which obey the above relation, Newton's law of viscosity, this relation which obey that fluid is called your Newtonian fluid, and which do not obey the relation, that will be called non-Newtonian fluid. Okay, now I think it is more clear that what is Newtonian and what is non-Newtonian. So which is obeying this relation, then it will be called Newtonian fluid. Now a very important question coming, that variation of viscosity with temperature. So in case of liquid and in case of gas, what are the variation of liquid and gas, and the variation of temperature in case of liquid and in case of gas? You will be seen it is basically uh, just vice versa. That means if in case of liquid what happened and in case of gas, in this lecture I am just covering up this one. So the temperature affects the viscosity. The viscosity of liquid decreases with the increase of temperature. You can see this is your viscosity, and for liquid it is decreases, and for gas it is increases. How? Just listen for a minute. While the it is increases increase of temperature, while the viscosity of gas increases with the increase in temperature. Why it is like that? This is due to reason that the viscous force in a fluid are due to cohesive and the molecular momentum transfer. The viscous force, what you are getting viscous force when the fluid is in motion, then there will be some viscosity, and because of that viscosity there will be some viscous force experienced. So that viscous force in the fluid are due to cohesive force and molecular momentum transfer. In liquid the cohesive force predominates the molecular momentum transfer due to closely packed molecule, and with the increase in temperature the cohesive forces decreases with the result of decreasing viscosity. What does it mean, cohesive force and adhesive force? Basically the attraction force between same molecule, it is called your cohesive force, but attraction between different molecules, like in your glass of water, attraction between water molecule to water molecule, that is called your cohesive force. But what is adhesive force? The molecule of the glass material and molecule of the water, that attraction, it is called your that means that is called your adhesive force. Because of the adhesive force the attraction is there. Okay. So in case of water, the cohesive force predominates the molecular momentum transfer. When the fluid is in motion, there may be some molecular momentum transfer. So the cohesive force predominates the molecular momentum transfer because it is closely packed to each other. The two liquid molecule, it is closely packed to each other, and the viscous force is predominant with increase in temperature. The cohesive force, with increase in temperature the cohesive force decreases, with result the decreasing in viscosity. Okay. So if the temperature is increasing, then the molecular momentum transfer, that means the cohesive force is decreasing. If the temperature is increasing, they are closely packed, the molecules, it is there will be some more space in between molecule, and the cohesive force will be decreased. And if the cohesive force will be decreased, then the result is your viscosity will be decreased. But in case of gas, what happened? The cohesive force are small. In case of gas, two molecules, that means two molecules are, the space between two molecules are more than water. Okay, it is not closely packed. Okay. So in case of gas, the cohesive force is small and molecular momentum transfer predominates. So here the main picture is your molecular momentum transfer. If the molecular momentum transfer is more, then what happened? The viscosity will be more, because with increase in temperature molecular momentum transfer will increase, isn't it? If the entropy is increasing, that means if the temperature is increasing, then entropy is increasing. The degrees of disorderness or randomness will be increased. So what happened? If the disorderness or molecular momentum transfer is increasing, then temperature is your viscosity will be increased, because there will be more collision between one molecule to another molecule. Okay. So that is why in viscosity is also increased. The relation between viscosity and temperature for liquid and gases are mu is equal to mu naught into 1 by 1 by 1 plus alpha t plus beta t square, where mu is the viscosity of the liquid at T degree centigrade. Let us consider at 30 degree centigrade what is the viscosity, at 50 degree centigrade what is the viscosity. So at T degree centigrade in poise you are getting the viscosity, and mu naught is what? Viscosity of liquid at 0 degree centigrade in poise. Okay, so we need to know what is the viscosity of that particular liquid at 0 degree centigrade, and alpha beta are the constant, and this mu naught for water is 1.79 into 10 to the minus 3 poise. Alpha is given 0.03368 and beta is equal to 0.000221. So it is already experimental value, it is given. So from this value you can find out for a particular temperature what is the viscosity, and we can see the liquid viscosity is decreasing with increase in temperature. Okay, now in case of gas, mu is equal to, it is directly proportional to temperature, in mu is equal to mu naught plus alpha t minus beta t square. So you can see from this equation, if all these values are increasing, then that means the temperature is increasing, the viscosity will be increasing, but here the temperature, it is your reciprocal, you can see inversely proportional. So from this equation you can easily find out how much temperature viscosity raised or decreased because of the variation of temperature. So this is all about the viscosity. Next class we will be discussing the type of fluid and rest of the lecture. Okay, so today up to this, thank you for listening. Jai Hind.